So this should be a bit of a revision lesson because we had a look at it a while ago in the case of when we looked at functions for the first time. So we're going to be referring to a lot of that knowledge. So that's the title, that's the learning goal. So let's get straight into it. It goes, find the inverse of the following functions. I don't know if you remember this, but we need to find the inverse, we need to swap x and y. So we write swap x and y. Okay. So when we do that, we can start. So we go x equals y plus 2 over y minus 3. So what we've simply done is that where there's a y, now there's an x. Where there's an x, now there's a y. So we're just swapping x and y because we want to find the inverse of these functions. All right, let's keep going with it. So I want to make y the subject on its own. So I've got, I'm going to multiply this one over there. So it's going to be x, y minus 3 equals y plus 2. And so what I'm going to do now is I'm going to ski jump here because I want to get all the y's together and everything else on one side. So let's do that. So we've got x, y minus 3x equals y plus 2. Now what I'm going to do is I'm going to send the y over. So we've got x, y minus y equals, and I'm going to send this guy over that side. So we've got positive 3x plus 2. All right. Now it's really good in this situation. I can factorize a y out. So I go y, and you've got x minus 1 equals 3x plus 2. Therefore, y equals 3x plus 2 over x minus 1. So all I've done is divided both sides by x minus 1. Now I'm going to put 2 lines down there. Now, I think I've done everything right. It looks like I have. So what I need to do is that's actually not the inverse function. I've just made something else up. So I need to summarize this with my inverse notation. So therefore, f of x is going to be this guy here. So 3x plus 2 over x minus 1. And there's one more thing, it just reminds me, is like, go f of x dot dot, so you know that refers to f of x. So then the inverse function becomes that. All right, so we're going to do the same thing for the next example. Like I said, it should be a bit of a, I'm going to draw another straight line here. Here we go. And I'm going to use a different color pen. So I'm going to go f of x equals this guy here. So let's do it. X plus 2 squared. So let's fix that up. Minus 1. So I'm going to go swap x and y. So I'm going to go x equals y plus 2 squared minus 1. So we need, the goal is the same thing. We need to get y by itself. So I'm going to go x plus 1 equals y plus 2 squared. So I've just moved this guy over to here. All right, let's keep going. So I need to get rid of this squared, so I'm going to square root both sides. So square root of x plus 1 is equal to y plus 2. Now there's one thing I've missed out on, and I'll put it up here, plus or minus. Okay, it's very important. And now there's only one more thing to move, so I'm going to move this plus 2 over to the other side, but I'm going to flip everything over as well. So I'm going to go y equals plus or minus square root of x plus 1, and then I'm going to move this minus 2, like this plus 2 to a minus 2 on the other side. So hopefully you can see that I've put y on the left hand side. Now I need to summarize this. Therefore, the inverse function will be plus or minus x plus 1, and I'm going to get rid of some of that, minus 2. Okay. So hopefully that's not too bad. You remember, yep, I've got to swap x and y, and yep, I've got to use this function notation to indicate that that indeed is the inverse function of it all. There was a second part to it, and we looked at this last time, and it's restricting the domain. So if I look at these functions, if I look at these functions, this is the same question. This is the drawing of them, okay? Now this one's interesting. If I rotate this by the y equals x, because that's what, if I reflect it along that axis, it's going to be a function as well. It's going to look something very similar to that. Whilst this one, if I rotate this one along that same axis, it's going to look slightly different. And I've actually got them here. Oh, yeah, I do. Well, I almost took this one away because it's pretty straightforward. So let's look at it here, okay? So I'm looking at this one now. If I rotate it around, I'm missing information here. So the inverse will look like that, okay? This will what the original one looks like, and the inverse will look like that. Now the problem with the inverse is that it fails the vertical line test, which means that the inverse is not a function. So it fails because it crosses in both sections. Because can you imagine if we twist this to the side, it crosses in two sides. So we need to restrict the domain to make it a function, and that's actually what I've done in these screenshots I've taken. Okay, I've restricted the domain, and I don't know if you can see it here, but I said that x, because remember domain is x, is going to be less than -2. So all I'm looking at is this part of my original function. And what I've done is I've reflected that. So I've reflected that here. Now, the inverse now with the restricted domain actually does pass the vertical line test. So he only crosses at one point in all these spots. So we're going to have to restrict the domain of the original function to make the inverse a function. Now, this is a really important concept, and it'll become more important in the next lessons as we look at inverse trig. And I just want to show you, vice versa, if I'd chosen this one, okay, so if I said that instead of restricting the domain of less than, if I said x is greater than -2, well, what I would get is the reflection would be this here and none of this here, which is also a function. So if we want the function and its inverse to be a function as well, sometimes we have to play restrict the function game. Peace out.